In the previous segment we learned how to name binary ionic compounds, and these were compounds that contain an elemental cation and an elemental anion. In this segment we will learn how to name binary covalent compounds. These are compounds that contain elements that are not metals, so they are either a nonmetal or a metalloid. In the first example we see nitrogen monoxide, which contains nitrogen and oxygen atoms, which are both not metals. So this is a molecule in which there is a covalent bond. The second example is sulfur dioxide. This is also a molecule with covalent linkages. So how do we name these binary covalent compounds? Here's a list of rules that we will follow. We name the first element first. That means the element that's written first in a chemical formula, we name first. The second element written in the chemical formula, we name second. And we name it as if it were an anion. In other words, the naming is very similar to the naming of binary ionic compounds, but there is an important difference. The difference is that we add a prefix specifying the number of atoms of each element. So, if the element has only one, we add the prefix mono. If it has two, the prefix di. If it has three, the prefix tri. However, we do not add the prefix mono to the first element. If the first element is only one atom, we do not add mono. However, if there are two, we do add the prefix di. So let's put this into practice. This is a compound containing phosphorus and chlorine. So we name the first element first, phosphorus, and then we treat the second element as if it were an anion, so it becomes chloride. But we do have to specify how many chlorines we have. It is phosphorus trichloride. Note that we do not add mono to phosphorus, because this is the first element mentioned. We do not add mono to it. The second example is a compound containing two nitrogens and one oxygen. This is dinitrogen monoxide because it contains two nitrogens and one oxygen atom. Let us now look at another important class of compounds. These are called acids. And acids are substances that when they are dissolved in water, they generate a H+ cation. How do we recognize acids? Well, it's not that hard. The chemical formula of acids starts with an H. For instance, HCl is an acid because it starts with an H. This is hydrochloric acid. The next one also starts with an H. This is sulfuric acid. How do we name these acids? Well, in naming acids, we first have to look at whether or not it contains an oxygen atom. If it does not contain an oxygen atom, we name the acid as follows. We take the name of the anion, and we add the prefix hydro, and then the suffix ic. So, in this example, this is an acid. It has an H in it, it starts with an H. It has the anion sulfide. We add the prefix hydro and then the suffix ic. This becomes hydrosulfuric acid. The next acid contains bromine anions. So we add the prefix hydro and the suffix ic. This becomes hydrobromic acid. Now what if the acid does contain an oxygen? In that case, we use the following set of rules. If the name of the anion ends in ate, then we add the suffix ic. If the name of the anion ends in ite, we substitute ite with us, O-U-S. For instance, here are two acids. They start both with an H. The anion in the first example is a phosphate anion. Phosphate ends in ate, so this becomes phosphoric acid. Note that phosphate is a polyatomic anion. The second acid also has a polyatomic anion, which is called sulfate. It also ends in ate, so this becomes sulfuric acid. The third example contains anions, polyatomic anions, called nitrites. It ends in ite, so we substitute ite for OUS. Hence, this becomes nitrous acid. The last set of substances that we will be focusing on in this segment are the so-called hydrates. What are hydrates? Hydrates are structures that incorporate water molecules as part of their structure. For instance, this compound here is cobalt 2 chloride with 6 water molecules incorporated per unit of cobalt 2 chloride. So this is called cobalt 2 chloride hexahydrate. The naming of hydrates is not that difficult. We add the word hydrate with the prefix specifying how many water molecules are incorporated per unit of the compound. For instance, this is barium chloride. It has 2 water molecules incorporated per unit of barium chloride. So this becomes barium chloride dihydrate. Another example is copper 2 sulfate. Note that copper is a type 2 cation. Copper 2 sulfate with 5 water molecules incorporated per unit of copper 2 sulfate. This compound is called copper 2 sulfate pentahydrate. In naming compounds, there's often many ways in which you can go wrong. And there's a common set of mistakes that I'd like to discuss. Let's look at the first compound here. This is a compound containing iron cations and chlorine cations. This is unfortunately the wrong name. Iron chloride is not correct. Why not? Because iron is a type 2 metal, which means I have to specify the charge of the cation. In this case, the charge is +3. That means this is iron 3 chloride. In the next example, SO3, this looks a lot like the sulfite anion. However, it is not. The sulfite anion, which is a polyatomic anion, has a charge of -2 because it is an anion. However, this compound is neutral. This is not an anion. This is a neutral compound, a binary covalent compound. This is sulfur trioxide. The third example is an acid. It is an acid with the anion carbonate. Now, sometimes you can call this hydrogen carbonate. However, in this case, you cannot. Because in this case, it is specified that the substance is dissolved in water. And if it is dissolved in water, indicated by the sign aqueous, AQ, we have to call this an acid. In this case, it's called carbonic acid. Another example. This is a compound containing selenium and fluorine atoms. This is not selenium fluoride, because this is a binary covalent compound. We have to specify the number of atoms. We don't specify the number of the first atom because there's only one. But the second element, we have to specify the number of atoms in the structure. There's 6. So this is selenium hexafluoride. And then finally, this compound containing 2 nitrogen atoms and 3 oxygen atoms. This is not nitrogen trioxide, because the first element contains more than 1. And in that case, we have to specify the number. This is dinitrogen trioxide.